Hey everybody, Mr. Snyder here. Today we are going to be talking about system of equations, but this time instead of substitution, instead of graphing, we're going to be looking at system of equations and using this method called elimination. My second favorite way to solve a system of equation. Now, here we go. For the most part, if you cannot isolate a variable very nicely, okay, elimination usually is your backup plan to solve system of equations, okay? I'm going to give you a quick review on how that works, starting with an easier problem and then working my way to probably like the harder of the three examples that I'm going to show you today, okay? So starting with the first one, all right, you'll notice I got x minus 3y equals 2, and I got 2x plus 3y equals negative 14. You'll notice that the x's are in a column, the y's are in a column, and the numbers and the equal signs are all in a column. Very nice, okay? So everything's grouped up by column, okay? And when you're using elimination, what you're going to look for is in each of those columns, you're going to look for opposites, okay? So if you look at that first column, we got x and 2x. X and 2x are not opposites. However, for the second column, we got negative 3y and positive 3y. Those are opposites. If I were to add those two together, they would pretty much cancel themselves out and get 0, okay? And the whole idea with elimination is, for the most part, is to get rid of one of the variables by pretty much making the variables, or either the x's or the y's, opposites of each other so that you can solve for the other variable, okay? So let's go ahead and show you like an easy example of this. So we already mentioned that negative 3y and 3y are opposites of each other. Let's go ahead and eliminate the y. So to do the elimination, once you get opposites for one of the variables, you're going to treat this like an old school addition problem where you just take the top and you add it to the bottom. And then you take the top, you add it to the bottom. So x plus 2x is going to give us 3x. Negative 3y plus 3y, well, that's just going to cancel out, okay? We get 2 plus negative 14, well, that's just going to give us negative 12, okay? So we're going to just drop down the equal and then the negative 12. And what do you know? I have a pretty easy equation to solve for x now, okay? So I'm going to get x by itself by dividing each side by 3. The 3's cancel over here, and I get x equals negative 12 divided by 3, which is negative 4, or quattro. Haha, I'm learning. All right, anyway, so we got x equals negative 4, and because it's a system of equation, we have to go ahead and get y as well. Now, none of these equations really are nicely or very easy to solve for y because none of them have like y equals like the other ones. So we're just going to have to pick one of those original equations and plug this in for x and then actually just solve for y, all right? I'm going to use the top equation. So I'm going to rewrite that because I kind of made it a mess up there. I got x minus 3y equals 2. And I'm going to use x equals negative 4 to plug in for x. So I got negative 4 now instead of the x because I'm going to use that information. And then I get negative 3y equals 2. Let's solve for y. So first of all, I'm going to add 4 to both sides because I want to get that y thing by itself. Alright, so let's do that. I get negative 3y equals 6. Now I got to divide each side by negative 3. Alrighty. Wow, this is a nice problem. Y equals negative 2 is the answer. Awesome. So let's just finish out by writing it as a point. So I got negative 4 comma negative 2 as my answer. All right, example number 1, done. Let's go to example number 2. Okay, let's hope that that's just as easy of numbers to deal with. All right, now you'll notice this time we have everything lined up in columns. Okay, so step 1 is done. However, there are no opposites. There's no opposite x's, no opposite y's. We don't really care about the numbers, but this time we're going to actually have to create an opposite. Okay, so if you look at the top one, I'm going to look at x's. I'm going to pay attention to x's. If this x were a positive 2, that would be opposite of negative 2 here on the bottom. I can't, it's not already like that. So what I'm going to do is I'm going to force that to be a 2x, okay? And to do that, I'm going to have to multiply it by 2x. Just by 2, okay? But if I multiply that by 2, I have to make sure everything else gets multiplied by 2. So the way I show my work for this is I just put a big old parenthesis around everything and make sure that this 2 that I'm multiplying everything by gets multiplied by everything, okay? So I get 2 times x, 2 times negative 2y, and then 2 times the 2 on the other side, the equal sign. And I'm going to rewrite this below that bottom equation, okay? So it's going to be 2x. I got 2 times negative 2y, which is negative 4y. And then I got 2 times 2 over here on the other side of the equal sign, which is just going to give us 4. Okay, make sure you separate that y with on the number with a equal sign. Okay, don't forget that equal sign. It's going to mess you up. Anyway, so now look at, I got opposites for the x's, okay? So that's just going to pretty much cancel when I add these together. I get 5y plus a negative 4y, which is going to be a positive y, equals negative 1 plus 4, which is going to be a positive 3. So I just solved for y, okay? Now, we got to plug this back into one of the original equations, okay? And I'm just going to use that first one that I kind of played with a little bit, okay? Just use the original equation. You don't have to really worry about anything much other than that, okay? So I'm going to rewrite this. I got x minus 2y equals 2, okay? I'm going to plug in that 3 for y, so x is not going to have anything plugged in yet for it. 2, let's plug in that 3 now for that y, equals 2, okay? Now, do some math real quick before we solve for x. X, negative 2 times 3, which is just going to be negative 6, equals 2. Now I got to add 6 to both sides. What do you know? This is going to be a nice answer as well. Very nice numbers. This is going to cancel. I'm going to get x equals 8 for my x variable or my x coordinate. Okay, so I'm going to write that one last time as a point. 8, comma 3. Done. All right, let's go on to the last example, and this one definitely I have a feeling is going to be probably the hardest, and yes it is, okay? Now, last time all I had to do was multiply one of the rows by a number to get it to be an opposite of the other variable, okay? This time, I'm going to have to multiply both the top and bottom row to get opposites, okay? Now, I like to do the same thing over and over again, so I like to pretty much stick to just that first variable that I see. First variable that I see are the x's. I notice again that everything's in the same column, like the x's are in a column, y's in a column, numbers in a column. My top x is 5x, and my bottom x is negative 2x. Remember back when we learned common multiples, what is the least common multiple of 5 and 2? If you guessed 10, you're absolutely correct. So I need to make both of the x's 10. One of them a positive 10, one of them a negative 10. Since the bottom's already a negative number, I'm just going to make that my negative 10, and the top one will be my positive 10. Now, how do I get from 5 to 10 multiplication style? Well, I got to multiply it by 2. So I'm going to have to multiply this top one by 2 to get the 5x to become a 10. And I'm going to have to multiply this bottom one. If you guessed 5, you're absolutely correct. I'm going to have to multiply this bottom one by 5. Now notice again, I'm not just multiplying the one thing I need to be opposites by whatever number. I'm going to make sure everything in that row gets multiplied by the same thing. Okay, so I'm going to start with the top row. 2 times 5 is going to be the 10x, which is what I wanted. 2 times 4y is just going to give me a positive 8y, okay? And then 2 times 10 is going to give me 20, all right? I'm going to put an equal there between the y and the number. All right, 5 times negative 2x is going to give me my opposite number that I needed, negative 10x. 5 times 3y is just going to be my positive 15y. All right, and then 5 times negative 27. I'm not the quickest at this, so I'm just going to go ahead and make sure I do this correct on my calculator, okay? So I got 5 times negative 27. And just making sure it's going to be negative 135, okay? So I'm going to have that equal to, whoops, there we go, negative 135. All right, now it's time to add up. All right, so I have 10 plus negative 10x, cancel, okay? Awesome. 8y plus 15y, well, that's just going to give me 23y. And I'm going to have that equal to 20 minus 135, which is going to be a negative number. You guessed it. And if you guess negative 115, you're absolutely correct. Okay? So 23y equals negative 115. I'm going to divide each side by 23, and I'm going to solve for y. Okay? If you're not good with 23s, just like me, I'm going to take negative 115 and divide it by 23. Let's see what we get. Negative 5. Awesome. So I got y equals negative 5 as my answer for y. Okay, don't stop there. We got to get x. So use one of the original equations, the ones before we multiplied everything, and let's use the top one to plug in for y and get x. Okay, so I'm going to rewrite that top equation again, like without any kind of stuff done to it, just so I can kind of keep the same method each time. 5x plus 4y equals 10. I'm going to plug in the negative 5 in for y to solve for x. 5x plus 4 times negative 5 equals 10. All right, 4 times negative 5 is going to be negative 20. So I got 5x minus 20 equals 10. I'm going to add 20 to both sides, okay? Okay, All right, and I'm going to get 5x equal to 30, okay? Now, divide each side by 5, and you'll notice that x is just going to equal 6, okay? So x is just going to be 6. We are done. So we got x, we got y. Let's just write it as a coordinate, and that will be our last example for the day. So 6 is the x coordinate, and then negative 5 is the y. Okay, this is where the two lines intersect. Okay, hopefully that helped. Okay, if you have any more questions or if you have any more concerns, call me on over and I'll help you out with elimination. Okay, have a wonderful day. Goodbye.